In our introductory class on complex numbers, we said that our z is the same thing as a plus bi. Now, if z is equal to a plus bi, where a here is referred to as the real part and b is referred to as the imaginary part. Now, apart from representing this as in rectangular form like this, we can also represent it using the Argand graph. Now, on the Argand graph, the y-axis will stand for my imaginary part, and also the x-axis will start for my real part. Now this, so that here on the imaginary part, I can pick my b, and on the real part, I can pick my e. So that if I pick this way, here is my e, and here also is my what? Is my b. Let's pick the diagonal. Now, so that the diagonal, I can now label the diagonal out. This diagonal is at an angle theta to A. Now, this gives me my polar form. My polar form tells me that this same Z is the same thing as this R is at an angle of what? Of theta. Now, from Pythagoras' theorem, you can deduce that R squared is the same thing as B squared plus A squared. So that R now will be the same thing as the square root of B squared plus A squared. At the same time, we know that tan theta, if you look at this carefully, tan theta is the same thing as opposite over adjacent. Now, considering the angle theta in this diagram, we know that the opposite is B and the adjacent obviously is A. So I can say that my tan theta is equal to B over A. So that theta is equal to the tan inverse of B over A. Now that means if I'm to look for the polar form of any complex number, all I need to do is to find the square root of the sum of the square of both sides. Now, what if I now have the complex number? If you have the complex number, if you are given the polar form of the complex number to convert to the rectangular form, that means I'm given R and I have theta. Now, the next thing is, if you look at, let's come back to this diagram, you agree with me that sine theta, which is equal to opposite over hypotenuse, is B over R, which implies that my B part will be the same thing as R sine theta. Remember that the B is the imaginary part. Then my cos theta from this same figure is the same thing as C over R, that's the adjacent over the hypotenuse. Now this implies that C itself is the same thing as R cos theta. Now if B is R sin theta and C is R cos theta, now I know that my Z is the same thing as A plus BI. In place of A, sorry, I said C, sorry, this A, there's no C in the figure. Now, in place of A, I can have Z to be the same thing as R cos theta plus R sin theta I. Let me have my I here. So that Z now is the same thing as R. Let's open the bracket. This is cos theta plus I sin theta. So from this, you can easily derive both your real part and your imaginary part and have your rectangle. Let's take some few examples to show us how to solve for each quadrant. Now, the first example says that Z is equals to 2 plus 5i. Now, I'll put this here. So that here is my 2. Here is my 5. My 5 is the imaginary part. And here is my 2. That's the real part. So that I have my triangle this way. Now, here's my R. Now, obviously, R is equals to the square root of B squared plus A squared. That will be, R now will be the same thing as the square root of 2 squared plus 5 squared. That means R now will be the square root of 4 plus 25, which is the square root of 29. Now, the square root of 29, let me use my calculator. For my calculator, the square root of 29 will be the same thing as 5.385. Now what's theta? Theta is the same thing as tan inverse of B over A. That's the same thing as the tan inverse of 5 over 2. So that my theta is equal to the tan inverse, that's the tan inverse of 2.5. Now the tan inverse of 2.5 is the same thing as 68.19. That's approximately 68.2. Now that means that I can now write my Z in polar form to be the same thing as Z now is the same thing as my R is 5.385 at an angle of 68.2. Now, one thing I want you to notice about this question is that this is in the first quadrant. Let's see the second question that will show us how to treat the second quadrant. Now, if you look at this carefully, now here is minus 5 plus 4i. Now 4 is positive, so I have 4 here, and minus 5 is the negative part of x, the negative part of the real axis. Now, easily I can take this up this way and have this as this my R. Now, in this case, here let's label what we have here. Let's label this beta, while here is going to be my theta. My theta is going to come from this way in an anti-clockwise direction. My theta is split in an anti-clockwise direction. Now, if you look at what we have here, my theta was split in the anti-clockwise direction. Here is theta. Now, so the same thing we'll do here. Our theta is split in the anti-clockwise direction. But one unique thing you should know from basic trigonometry is that the angle beta in here is the same thing as 180 minus theta. Or if you want to put it the other way around, theta is the same thing as 180 minus beta. Now, what is beta and what is theta? So that first of all, let's look for R. R is the same thing as the square root of B. My B now is 5. And my A obviously is 4. That's 4. Which is equal to the square root of 25 plus 16. That's 16. That's the square root of 41. That's the square root of 41. So what's the square root of 41? That's 6.4. The square root of 41 is 6.4. Now, if my R is 6.4, my tan theta is the same thing as B over A, which is equal to 4 over 5. 4 over 5 is the same thing as 0.8. So that theta will be the tan inverse. That's the tan inverse of 0.8. Now, so that theta in this case, or sorry, beta. Sorry, I'm used to theta. This is beta in this case. Beta in this case will be the same thing as, what's the tan inverse of 0.8? That's 38.66 in degrees. So that if beta is 38.66, now my theta, remember, is the same thing as 180 minus beta because of the quadrant I'm working in. So that theta in this case will be the same thing as 180 minus 38.66 equals to 140 from my calculator. That's 141.340. Let's see another quadrant. Now, in this case, I have Z to be equals to 1.5. 1.5 is on the real axis and is positive. And let's tag this point to 1.5, while my imaginary part is negative. That's 2.6. Now, let's see this. Now, here's my R. So that in this case, I'll be picking my theta this way. Here's my beta. Let's call this my beta. But remember that my theta must go anti-clockwise. So here is going to be my theta. Now for this case, you know that in this quadrant, your theta, my theta in this quadrant is the same thing as 360 minus beta. This is what I really want you to observe here. So that R now is equals to the square root of 1.5 squared plus 2.6 squared. R now will be the same thing as the square root of 1.5 squared plus 2.6 squared. That's 1.5 squared. That's 2.25 plus, and the square root of, and the square of 2.6 squared. That's the same thing as plus 6.76. Now 6.76 plus 2.25, that's equal to 9.01, and that's approximately 3. So that R now is the square root of 9.01, which is approximately 3. Now if then theta or beta rather, beta in this case will be the same thing as B tan inverse of B over A, which is equals to tan inverse of B. My B in this case is 2.6 and my A is 1.5. So that's equals to tan inverse of 2.6 divided by 1.5. That's 2.6 divided by 1.5. 1.733. So that the tan inverse of 1.733, that's equals to 60 degrees. That's equals to 60 degrees. So if beta is equals to 60 degrees, obviously theta is equals to 360 minus 60 degrees, which is equals to 300 degrees. So I can write my Z to be in the form of 3 at an angle of 300 degrees. Now with this, we've shown you how to treat complex angles or how to represent complex angles in polar form. If this is the first time you're visiting our channel, please don't hesitate to hit the subscribe button. That way you'll be telling YouTube you love what we're doing and you'll encourage us to do better. Thank you. I'll see you in our next class.